Perfect.
Good morning, Shanka. We can
Perfect. So let's review what we have discussed in the last class. So we finished a concept of Spark Core where we saw some optimization techniques. Like we saw how we add parallelism. We also saw that how we do the caching or persistence, and we saw various type of persistence within it. So one persistence we have discussed, which is default, is your memory only. Then we have disk, and then we have memory and disk both. Now, within this also we discussed various components, like you can either replicate it, or you can even have a serialization methods on top of it, and can have all these RDDs persisted to decrease your processing time a lot of times. And we saw various scenarios where they all fit in. Now, today we will be talking about Spark Sql. Very awaiting topic and very important topic as well. But since we have spent a good time in Spark Core, now Spark Sql will become a lot easier. And we will be also seeing how to work all this in the Databricks environment. Means how we can run all this on the notebook. Okay, so I will also be showing you that today. Just one thing before I move to this, I want to give you maybe again, something from my industry experience on this parallel part. It will be really quick, but it's something which will be helpful for you. Remember, I told you that whenever you have some query, like for example, you say sc.text file, you give some file name, comma, you give whatever parallelism you want. Not only this, even let's say you are writing reduced by key. There also you can define your thing. In the last, you can define what's the parallelism you want for it. All those things you can actually do it. Now, one basically experience I tell you from a company where we went, and what they were doing was they were adding all their parallelism. So what they were doing was, let me give you this example with one core and basically one machine, and then you can relate it with multiple machines also on your own. So let's say you have a machine, okay, and let's say you have, let's say some 10 cores available to you. Okay, 10 cores means you can have 10 parallel threads which can run basically from your machine. It could be one machine, two machine, doesn't matter. Now, what we do generally, we have a tendency that whenever we are working across with this, let's say we have one Spark job running in. So for that company also, we had something similar scenario, just that their number of cores were much more than this. So what they were doing was they were running just one Spark application, which was a very heavy application. Now, what they had done was, generally what happens is, like if you have 10 cores, maybe 2 cores might be getting used for operating system. Okay, maybe 1 core for running for your rest of your applications. So you have, let's say, 7 cores idle, right? You have 7 cores idle. So what they had done was they took all these cores, they were running some Spark command, and what they thought, okay, let's have this Spark running. We have only one application, 7 cores are free. Let's use all the 7 cores in as my parallelism to have like faster results. What do you think would happen? Do you think this would be a good idea? And this is an exact scenario for company, I'm telling you. It's just that I changed the number of cores, that's it. But they decided to use all the 7 cores to give the application after kind of taking a call that how many are free across cores. Now, what do you think would happen? Do you think it's a good idea in terms of parallelism, bad idea? What's going to be this? And this is a very recent example, actually. That's the reason I thought to bring it up in front of you guys.
I guess no.
No means
because
what?
No, because we should not be using all the cores available. So
Okay.
means like 90% or 95% of if you use that many cores, the machine will have some mechanism for if something devastation happen, it can change the.
Mm-hmm.
I mean,
Gaush is suggesting that we should be using maybe 5 or 6 cores. Am I right, Gaush? In this case,
Yes, yes, sure.
that would make the things optimal. Okay. Any other answer? Or maybe you can add to the thought process of Gaush also. I'm okay with anything. Girish, what's the thought from you?
Yeah, Shivank, sorry, I'll let others answer. I was looking into something else. I'm really sorry.
Okay, no problem. Arun, what's the thought?
I mean, if you occupy all the cores, like what if OS wants to start some other process or something,
So let me ask you
or a
first.
bottleneck?
Arun, let me ask you first question. So do you agree with Gaush or not agree with Gaush?
Yeah, I agree with him. Yeah.
Agree with Gaush. Okay. Now, can you tell me what should be the number of cores as per you? 5, 6, 3, 4? Because you said lesser. So how many numbers we should go with?
If there is a way to uh, change it based on the availability,
Availability, let's say I know. Let's say 7 cores are completely free all the time.
not sure.
Then 5 or 6? Okay.
Oh, yeah.
Yeah. Aditi, any thought?
Even I agree with Gauss. I was thinking along the same lines that we should not use all the cores because we may need the code for some other operations, maybe input, output, or I'm not sure, some other operation other than just running the code. So we would need a lesser number of cores, but again, I'm not sure how many cores less.
Okay. Let me pick up one more person. Subi?
Same opinion, Shivank. I think the same. If we occupy all the cores, then we'll be left with no room for further processing any kind of uh, failure or backup, any kind of planning that will not be possible, right? So at least 20 to 30% of the availability should be there for fallback and all.
Okay. Anybody else who have a different thought than Gaush or all these people who just said? Anyone who want to contradict with this? So people say that we should need less cores. They don't know the exact number, which is completely fine. But they said we should definitely have lesser number of cores being used. It should be lesser than 7. If I have 7 free cores, I should be using lesser than 7. Anyone who is contradicting with this statement? No one? So all of you are wrong. Let me tell you the thing. What was happening for their application was when they were running the Spark application, they were taking somewhere close to 1.5 hours. In fact, to be precise, if I have to tell you, they were taking 102 minutes to run their application. Okay. They hired me as a consultant, and basically there were a lot many problems, but this was one thing which they were stressing on, that it takes 102 minutes because our processing is very heavy. In fact, they were doing a lot of ML stuffs on it. And they were really worried, can we do something about it? And let me tell you, they have very smart engineers, very, very smart engineers to handle this. So they have already written well-written code where I couldn't find any flaw to kind of go and fix things which can optimize this. Yes, there were few minor things here and there which I did and was able to make it to close to, with those fixes, to 95 minutes, which is a very minimal, right? Minimal. Just by doing some here and there code changes, I was able to bring it to 95 minutes. But what's the what's the deal with this, right? It's still less. Now, what was the solution? The solution was sitting into the parallelism. Now let me tell you what just I did. I increased this number of cores to, so let's say if this was 7, I made it now to 16. I doubled it and even increased it to more. Why? What happened with this? Let me first tell you the impact of this. Just a small change with this regard. This small change brought this to 32 minutes. Huge change. Okay. Now, definitely their number of course were different, but still I'm just giving you this part that I doubled it and increased some number, added some number to it and put that number. What happened? What exactly made it to 32 minutes? It's surprising. The core should be lesser. How come increasing the number of course increase my performance here? Now let me tell you what happens. I'm assuming that all of you here are coming from computer science background. Is there anyone who is not from computer science?
I am Shivank. I'm from Telecom.
So there is a topic you all must have learned called as operating system. Okay. In this operating system, you must have learned a concept called as context switch. People who are coming from operating systems and all those topics, you must have learned from computer science department. You must have learned about it. I'm not going to go too depth into it because it will become our operating system and I can talk about 1 hour completely on it only. So I will keep it very quick on this part, just to give you a very high level idea of what's going to happen. So what happens is right now, if you say that, okay, I'm going to use 7 cores, okay, which they were doing. So what's going to happen is, let's say there is one core which is occupying, basically on one core, there is a process which is running, okay, and it went basically for some wait, maybe due to input output or something. It may be just looking for some resource from somewhere. Now in this case, what will happen? This core will get blocked. It will wait. It have only 7 cores at the time and it will wait. So how it works is like 7 threads or 7 process. So 1, 2, 3, 4, 5, 6, 7. 7 process will come and it will wait that once it over, then it will send the next batch for it. So now what will happen as soon as it will, because this process work is not complete. So what it will do, it will say, okay, I'm waiting for my resource and it will keep waiting till the time once it gets it, it will complete and go away. So that's a challenge. Now let's say you increased it to 16 number. Now what can happen? Let's say this process comes in, it occupied this core. It went for waiting. Maybe it was waiting for printer or it may be waiting for some input output. Meanwhile, another process which is sitting in queue will immediately come in and start using this core. Okay. So in case if there is no waiting, basically in the best case scenario, what can happen? In the best case, let's say if I have 7 cores, 1, 2, 3, 4, 5, 6, 7. Yeah, 7 cores. Maybe all the process which came have no waiting time. They all finished their work. So in that case, so what will happen to, because you have taken 16 process, that means you have 9 more in queue. They will keep waiting. It's okay. They will keep waiting for you. 9 processes. And once they are done, then they will go and start occupying them, which is okay with them. But in case if any one of it will also go into the waiting process, immediately from this queue, one will get picked up, will start doing its job. And basically that way, once it will complete it, once it will get back its resource, it will also complete it. So what happened in this context switching time, whatever we are working on, it will make the things really, really fast. That's the reason. In fact, it is recommended, and this is nowhere written. Okay, my recommendation is always have it from 2x to 2.5x. I have done a lot of experiment on it. When I increase it to beyond 2.5x also, I didn't find much usefulness. Means it will not degrade your performance, but it will not even upgrade your performance. But between 2x to 2.5x, when I played around this number, I really found the good optimization changes happening there. So this is what experiment I've done. Even I've done it with 1.8, 1.9 also. Still, this was like in the best category. I've done it with my multiple projects this time. And every time I have received success. And this is again, you will not find it in any book written. When you will also work on your projects, you have to also do a lot of experimentations to see that which will work for me, which will not work for me, and so on. So that's, I thought it's one of the critical thing for you also guys to know, because if you are just having such a good performance improvement by just introducing a small change in parallelism number, you can imagine the power of this, right? No code change, nothing required, just a small change, and see the power impact of this. Everyone clear on this part?
Yes, sure.
Shivang, this in operating system, what we call like idle time, it is what doing is it simply reducing that idle time of the codes, right?
Correct. So in operating system, you must have learned there's a chapter called as deadlock. So it's not just waiting time, but in fact there is a lot of other things. Like there's a waiting. In fact, there are some 5-6 stages which a process falls through, right? So it's not just one waiting queue, but there is a lot of other things also which also reduce or sometimes blocks your resources. So for all those things, basically it will ensure that it will just send another process so that we don't waste up the time of the core. Any other question, guys, on it? And guys, these small things really matters in your project. You keep learning from book, you keep doing mugging up all the stuff. It really doesn't matter unless and until you really know how to optimize your application. That is what going to make a big impact to your client. Yes, sir. So we were asking something.
Shivank, I just wanted a quick summary. I think this is really important and I want to make sure that everyone understands this. For me, I would like a quick summary once again.
Sure. So what you should always do is whenever you are developing these systems, because this thing will come in the last, you will decide your cluster, you will see that where your nodes, let's say you know that, okay, all your data nodes have whatever you have this many number of ports available in which my replica copy is this and all that. Now you have to, as a developer, take a call that, okay, how many cores will be free at a time, which I can use it to run my application. That's number one. Once you have the number of core calculation, do not blindly go with that, because you have to also see how many cores are getting taken away by your operating system, by some any other application which is running up. So you can basically get all these details as well. Now once you have all these details with you, then after that see how many number of free cores you have. Once you get the calculation of your number of free cores, ensure that when you apply your parallelism, try to do experiment. Don't go blindly with this number, because every application could be different. This is just from my experience, at least coming from last 23 projects, where I have done this. Okay, 23 Spark projects where I have experiment with this, that any number between 2x to 2.5x when it gives to number of cores, that really helps. But again, as I said, this is my experimentation. Maybe, and I've done it only on a sample of the project, which is the 23 projects on Apache Sparks. So you can definitely still try to do some hit and trial to see which is giving you a better performance, and then take a call as well. But basically this, if you put the number of cores to this will really help you to improvise on the performance. Why it do that? Because what happens is you have cores, and a lot of times what happens is that when you send the process, some processes can go into waiting queue, because it might be looking for some other resources. It may be waiting for some input output operation. It may be doing anything in that regard. So in those cases, whenever this gets into waiting, your time of the core is getting wasted, because it just keep waiting. So instead of that, since you are now bringing more processes in queue, so what it will do, whatever the waiting process will be there, that will immediately go and start occupying that core. So that what will happen is, as soon as it will keep waiting, but it will let this green process to finish. And once this finish, maybe then again this process can come back and finish the work. So that way we are ensuring that there is no idle time, no waiting time at all for the core side. Your core is always busy and giving you the optimal result. This is the whole summary of whatever we have discussed with respect to the parallelism. Clear everyone on this part?
Yeah, sure. Like it's kind of so we only have like 7 cores, right? Like, how did you land on the thought of like increasing cores like by that much? I mean, what was the thought process like? How did you land on that?
Okay, if you want to ask me like how I landed up with that, because we have actually tried everything out. In fact, to be really frank, I also tried to decrease the number of cores. So in fact, I don't remember the exact number for that client only, but if I'm not wrong, they had like a good number around some 50s, somewhere close to that. We even try to decrease that. As soon as I decreased that, I noticed that the performance even degraded further. That became even more bad. What I did was I started increasing it. Slowly, I started increasing it. In the initial number, so let's say if the number was 7 and I made it, let's say 8, it didn't have any improvement. I tried with 9. I saw slight improvement with that. That made me curious that what's happening around it. I started kept on increasing it using a binary search algorithm. Like I moved suddenly to a bigger number, which is let's say 12. I again saw a performance improvement. The idea was I wanted to see with 12, if the performance degrade, I will come down. Otherwise, I will move up. Then I will again start moving up, and I started seeing 15. And then I started noticing a major improvement in performance coming up with this. Then slowly I realized that this number is always falling between 2x to 2.5x. As soon as I went beyond some number, it started degrading. Definitely, it was still better than using the 7 course altogether, but still it started decreasing if I compare with, let's say, 16. It started decreasing from that number. Then I kept on doing that experimentation and I realized it will not work after beyond that number. And I come back and started doing the experimentation between 2x to 2.5x. And that made me realize that this is improving my performance.
Okay.
And yeah, then after that, it just became a history or story that I started doing it in all my further projects, and I started seeing a vast improvement in this. Okay, any
Okay.
other questions? Yes, Abhi.
I have multiple Shivang, but I'll hold my thoughts maybe for my personal research work. But did you come to conclusion that why exactly is it happening? Why is it degrading after 2.5x?
Basically, it didn't as such degrade, I would say, but there was no performance improvement. So it was
Not
something like, you can say
okay.
if I'm getting 32 minutes from this, then maybe I'm getting 32.4 minutes, something closer to that if I'm going beyond 2.5x. And the reason could be because you're trying to, when you're bringing more threads also, they're also sitting in waiting queue, right? It's also eating up some memory here. When you're also burdening your queue. So it's not like having too much impact, but definitely it will have a slight impact, right? So that also you need to keep in mind because you're increasing the size of a queue too much by the way. So that time sort of getting added at which you're seeing like 0.4, 0.3, slightly around that.
Understood. No considerable improvement.
So why you want to make unnecessarily waiting then? Let's have
Right.
it. That's what the instance which I had been. But in this context switch, then I have done a lot of reading apart, and then I realized that yes, this is the reason it is happening. So that's how I came to know. Otherwise, I was also in dilemma why this is working well with 2x to 2.5x. Then I have to do a lot of research and reading around it. Any other question? Okay. Now let's move to Spark Sql. Now, let me first give you a high-level insight how this Spark Sql came into picture, what were the things belonging to it, and so on. Now, let's say this is my HDFS. This is my MapReduce. Oh, sorry. This is my HDFS. This is my yarn, sorry. This is my MapReduce. This is my Spark. This is my Hive. This is my Spark Sql. Okay, this is my Spark Sql. So what was the approach my Apache Hive was taking here? So there was a meta store, which is my SQL DB. So what Apache Hive was doing, whenever I was querying something, it will first always go to the meta store. From meta store, it will, once it reads the data, it will convert the program to your MapReduce, will go to your HDFS, will read the data from here because it got all the details from metastore, and then it will execute it in the MapReduce way. Right? Let's ignore all those framework of Tej and all that, which came up pretty later, but basically this was the initial idea about Apache Hive. Now, where the things really became slow? Have it became slow when we were reading the data from Metastore, or when from Metastore we were reaching to SDFS, or when we were executing using MapReduce? Definitely MapReduce, right? That is what just happened when we executed in this manner. Now, the slowness came in this step, like we discussed. Now, what happened with Spark Sql? Spark Sql will also go and access the same Metastore. No difference in that. From this Metastore, it can also go and read the file from your SDFS. Now the execution will happen in the Spark way. Now notice the difference. This was the reason of making it slower, and this is the reason for making it faster. That's one of the major difference which it comes when you're going with respect to Spark Sql. So I just told you at a very high level how these things looks like. Now, another thing, how your work will happen when you're working with respect to Spark Sql. So here, let's say I have my data nodes like this. Now I have a table, let's say an RDBMS table, which has something like employee ID, employee name. Okay. Let's say employee ID is 1, name is A, 2, B, 3, C, 4, D. Okay, let's say this is the situation. Now, if I have to store this in the form of RDD, the way we were storing the was, we would say, okay, in data node 1, I will store it like 1, comma A. In this, I will say 2, comma B, right? Remember array of string? That's how it's stored. And here it would be maybe 3, comma C, 4, comma D. This is how I was really storing all this component up into my simple RDD. But the problem is now, I have lost the column names along with that. I lost my schema if I store it in an RDD way. Now, how about if I can store it in a little different format? Means along with my column details, if I can store it. What I mean is something like, though exactly it will not store it like this, but just to give you a small idea. So here I store it somewhere like this: employee ID, name, 1A, 2B. Here, let's say I store it like employee ID, name, 3C, 4D. How about if I store like this? If I store like this, then in that case, it will be much better and much faster. Why? Because now what is I'm doing is I'm storing the details about my column names as well. So basically what we are doing is we are defining now more like a structured format, number one. And second thing is we are also kind of storing it along with all these details. Schema details makes the query time faster, right? If you recall how we were writing the query there, select some column name, let's say employee ID, comma, name from my table, something like that we hit. So now since I have this schema details along with me, it will make things faster. Just to give you one example. In RDD, whenever I have to do some processing, I have to have this whole thing loaded together. But when I'm working with this, let's say I have more columns to it, maybe some more columns also. But let's say I only want to access name from it. Then in that case, I may be only required to take up this much and do the processing whatever required. Maybe I'm just saying that, hey, convert all the name to uppercase. Now in RDD, what I have to do, I have to load the whole thing together, then work on it. In a data frame way, how it happens in data frame, we will see that later. There are methods, encoding techniques and all that. But what I'm doing is I'm specifically only targeting that column. It will only load that portion. And that loading will be, now you can perform the processing on top of it. So with this, now what's going to happen, you are going to basically do the processing on that particular schema column which is required. So that makes the query also a little faster. Plus, if you are assessing something, again, that will make things faster. That's one thing. Second thing also is, even with respect to storage, the way data frames store your data in your storage part, that occupy lesser space in comparison to your RDD. Okay, because it uses its own serializations and all that while doing it. I will talk about it more once I explain you data frames and data sets across. But for now, just keep this in mind. Let's say if you have an RDD, and that RDD is, let's say, of size, let's say 1.5 GB. Okay, you convert that to a data frame or a data set. I have not introduced you with data set yet, but let's only say data frame. This may be just 600 MB. I just give an example. It could be a little more or a little less. So the way data frame stores your data also, it also eases out on your memory as well, because now the storage is little lesser. That's also one advantage what you get when you're working with respect to your data frames. Clear, everyone, on all these components we discussed? Okay. Now, so we just understood about what is a data frame by now. Now what I'm going to do is, I will show you some basic components of the things, how it works with data frames, using again the book, so that you get an insight how this data frame sort of gonna be look like. Once this data frame is gonna be, we will be seeing all the APIs or the SQL commands with it. Then further to that, what I'm going to do, I'm going to take you to the Databricks. Mostly Databricks will take a complete 1.5 to 2 class, because I will be showing you or teaching you this Databricks thing with the case study itself. It's going to be pretty huge data. So today we will try to at least set it up and made it ready for tomorrow class. Okay, but before that, let's see a few more things.
Shivam, how it is converting like 1.5 GB to 600 MB? Like it's in any compression or any filtering happening here?
So it's basically stores it in the format of array of row. I will come to that actually, how this storage looks like. Plus it also do its own encoding and all that. Like for example, if you store it like a data set, it have its own encoding, which makes the deserialization process also a little faster. But that encoding basically helps to compress the size. Okay.
Yeah.
Remember, I gave you one example, I think yesterday also about encoding. Let's say you're storing like this. So you can store it like A414, right?
Yes, byte array.
But same way it also have the encoding, which is there with data sets. Data set is actually a little more optimal. I will come to that little later. Okay, so we just understood about this part. Now, one more thing which I want to tell you is just that we have discussed about Spark context. We also, in order to work on Spark Sql, you have something called a SQL context. Okay, we also have something called a SQL context. Now the SQL context is the entry point for it. But now you can say, but I told you that Spark context is the entry point for everything. So still Spark context is the entry point for the Spark application. So SQL context uses Spark context. Okay. So SQL context, you can say, is sitting on top of Spark context. So without Spark context, even you cannot create SQL context also. So, but for doing all your Spark SQL query, you will be basically needing a SQL context. That's number one. Now there's one more thing. You can also write your Apache Hive queries along with your basically with respect to your Spark SQL. We have already discussed that. We will see it now, what exactly going to happen. So number one, when I said Apache Hive query, you can write it. Yes, you can also do it with the help of SQL context, but only very basic Apache Hive queries are supported. If you want to do some complex stuff, then in that case, to run Apache Hive query, you again have something called as Hive context. Okay, we will also see to this part. What is exactly this? Now, one more important thing. Since they became so many context thing came up in Apache Spark, that's the reason what basically Apache Spark did was they came up with something called as Spark session. Spark session in your Spark 2.x. So starting from Spark 2.x, now we have something called a Spark session that have all the context within it. So that you need not call them separately and keep on creating those objects and so on. So in order to save you from that, that's the reason they came up with something called as Spark session. Now, one more important thing. Why they decided to support Apache Hive with Spark Sql in this way. In fact, to tell you the history, earlier they came up with this project called as Shark. Shark was very old and it was not fully data frame centric. I have used it actually. It sounds more like a RDD, where the operations were very RDD based and it was not very optimal also. So what they did was they rewrote the whole architecture, completely rewrote it. And what they did was they then renamed the new architecture as Spark Sql. This is how this whole thing came up. So this Spark Sql came up basically from the Shark, and Shark project went into maintenance mode, and now I think it's gone. Nobody uses it. But when it came in starting, even I have used it. It was really bad in terms of performance. Now, then we came up with Spark Sql. Even like I said, right, storage optimizations and all those things were not there with Shark. With Spark Sql, they have added all that. Now, once this Spark Sql came into the market, it really hit it all very well. And basically, there were a lot many optimizations that were feasible with that. Community was really happy with it. But they did, I would call it a mistake, though people don't call it as a mistake. But what they did was they actually have a little different syntax than your SQL. They adopted a little different SQL syntax. Just to give you an idea, like for example, if you have to write a query in Hive, you would have said select column one from table, right? You will write like this in your SQL. In your Spark SQL, you will write it like this: t dot select column. Okay. So the syntax adopted was little different. It's a shorter syntax, but at the same time, there got involved some learning curve around it. If you have to change from this to this, it will be definitely a small change around which will be required with this. Now, people were happy with this. They thought, okay, it's a shorter syntax, looks great, everything is fine. But there were companies who already have, or basically they were working on Apache Hive from a long time. Very good time these companies were working. And these companies, though they were really happy with the performance of Spark, they want to use everything, but they were still not moving to Apache Spark. That was one challenge which was continuously happening with this. They were still not ready to move to Apache Spark because they said, hey, we have such a huge code base that we can't even think of just changing your code to your Spark SQL syntax. It's not feasible for us. We are writing this code from last 5 years or so, or 10 years, whatever. So we are writing it from so long. We have such a huge code base, it will not work with us at all. And that's where they started supporting this Apache Hive on top of Apache Spark. And this became a deal breaker, completely deal breaker. I do remember that after this change, so many companies just blindly moved to this framework. Earlier, what was happening, people were just thinking about, okay, let me use Stage, let me use LLP and all that, and I'm okay with that. They are faster, no doubt about it. But at the same time, introduction of Spark SQL have added a lot more things to it. In terms of not every query, but a lot of queries became a lot more performance friendly. Secondly, sometimes you have this data frame data also coming, let's say like a stream, you also want to create some graph because Spark have all these things integrated well. So you can also use those functionalities quite well. So it gives you much more better advantage over basically Tej and LLP queries as well. You can do a lot of stuff with it. So that's the reason now a lot of companies started moving. Still, a lot of companies have not moved, to be frank. There are still companies who are okay with this. They're saying that, hey, our queries are good enough to be running on Tej or LLP. We are all okay with that. But I would say a lot of companies have still moved to Apache Spark now. And since after this movement, what they did was they said, hey, you have your Hive query. No need to learn of my syntax. You go ahead and run your own query and we will be okay with that. So that was where this Hive context start playing the role. That using this Hive context, you can go ahead and start writing your SQL. Everything will work in the same way. You need not go and learn anything new, and still you will get the faster performance with it. So this is the overall story, how this thing actually came up. What is the slight mistake what these guys did? They could have come up with the same syntax. In that case, they would have no problem with that. But now they just added this as a Hive support. Okay, if you have an existing Hive code, you bring it in and everything will work for you. So they did everything in a very smart way after that. And now that's the reason I told you when I taught you Apache Hive, even after Spark coming into picture, have not lose its charm. It is still famous. In fact, it is much more famous. Hive queries are still being run a lot, and people are really, really happy with that. In fact, there are lots and lot of still research going on. Just to give an example, I'm not sure if in this class anybody have used GCP yet. GCP, Google Cloud Platform. In Google, I'm not going to tell you how they do it, but just to give you some idea, if you want, you can go to a component called as BigQL. That is nothing but your HQL. HQL is nothing but your Hive query language. Okay, so it's nothing but your Hive only. You can write your Hive queries. It is much, much faster in comparison to anything. You compare with Spark, you compare with Tej, it is much, much faster. And a lot of people just work on GCP because of this component. I know a lot of my own clients who are using GCP because of this. It is that great. Okay, so this big QL is like hitting in the market. In fact, you will be like surprised to know Microsoft, who have their own Azure platform. I know few teams who are using BigQL within that. So this is the fastness in this query. They have made it patented.
Shivang, do you mean BigQuery by BigQL?
Yeah, BigQuery. I just named it as BigQL. It's whatever you want to call. Yeah. So
Yeah, that's columnar, right? That's why it's fast.
yeah, they have done not many other things also within that. Even the execution frameworks also they have named it basically in their way, and it's much more faster. You can write your Hive queries on top of it. I myself use it for a lot many stuff. It's really fast. So people are still doing experiment. Companies are coming up on their own cloud with their own patented way and making things faster and faster. And that's where this is the now an open challenge in the market. That's the reason I said whenever you're working on big data projects, Google it will easily dominate over everyone. I have worked on all the clouds, but GCP you cannot beat in performance when it comes to your big data environments. They have so many things with it. Okay, so that's something you have to keep in mind. Basically, when you're working across with it. Okay, I think Subi, you said big query, right? That is little different. That is related to HBase. They have big QL also. Okay, now that's one thing you have to keep in mind when you are working, that when you're choosing for a client also any of the project. The reason I talked about it bit, because you should also be aware about these offerings from different clouds. You should be well aware of it, because you guys are also going to act like a consultant. So as a first thing, what you should always propose is, okay, given your problem, probably this will be best answered with this cloud. What do you think about it? Should we go with that? Do you have this framework available, or you want me to set up this framework for you? And you have to give your valid reasoning around that, because maybe you have some components there which are a little more tailored with that and could give you better performance in this with respect to the beginner level cloud or what is there with the open source community. Open source community is fine, but on top of this open source community, people what they have developed, which definitely they are costing you, they made your performance much faster, and that's the reason companies are pretty much okay to take up that. So you also need to have that level of knowledge across with it. For example, if you have an application which is more related to Windows, think about Azure. Azure is really good with respect to that. Similar way, big data, like I said, is really good across with respect to all the GCP component. Any open source thing you want to talk about, like Amazon is pretty good with that. Again, let me not go into that because that's a big topic, but this is what I generally do. I don't blindly say that, okay, let's go with the open source, unless and until the client is specifically pushing for that. But you have to really think hard that what I can do to basically save the cost or have a better performance, what they are looking for, and accordingly you can also act. So this is going to be an important thing for you. And one more thing which Spark Sql have, they also have something called as Catalyst Optimizer. This also sort of help you to optimize a lot of your query. In fact, remember I told you something called as a logical plan. It converts to the physical plan. It's basically work around that. So it uses the catalog, it uses the schema to ensure that whatever query you are writing, it will go on top of it. And basically what it will do is it will go ahead and execute all of your results really, really fast. Because what it do is it's again uses the logical plan first, which is just like in Apache Spark, I explained you, right? We have a logical plan, which just tells you that, okay, I have these operators, which I have to perform. But when it converts it to the optimal logical plan or the physical plan, that's where it's a deal breaker. It takes a call. Okay, what is the schema I need to use? Think about again the same example where I was just telling you that, okay, if you have, let's say, lot many columns with you, okay, I think that's somewhere back. So if even if you have lot many columns with you, I just want, let's say, from C1, C2, and so on, I need maybe only C2 column. So it will also ensure the optimization at your column level and say that, okay, I need to only fetch this data. I don't want to load the overall the whole data for you because I need only this much, and I can optimize my query that way. If you want, I can give you some link to read about Catalyst Optimizer. What are the activities they do? It's definitely could be a huge topic to talk about. But you really need not know each and everything that how we do that. But if you're curious, then definitely yes, it will be a good, interesting read for you. That what are the activities it do perform to ensure that it converts it to first of all an optimal logical plan. From there, it creates multiple physical plan. From that, it again go ahead and say that, okay, which is the best cost-friendly physical plan, and it choose the one out of it. So it do these many activities to get to the results, and it's really fast to get around that as well. So that is something which basically you also have to keep in mind, that this Catalyst Optimizer also helps. And that's what makes a difference when somebody comes and say that, hey, I have Page installed with me. I have LLP installed with me. Why I need to move my Apache Hive to, let's say, Spark? I'm okay with that. Yes, you could be okay. But there are some more optimizations which Spark can bring in, which probably those Page framework or LLP could not help you with. Yes, they are helping you, reducing you from not going to map reduce sections and all that, but still Spark is much more optimal. I would say it's much more powerful. But if you think that you are still okay with your existing performance of Page, then fine, you can stick with that. That's what a lot of companies do. They say that, hey, I know map reduce takes a lot of time. We were not okay with that. But with Page, I'm okay with it. My data scientists or data analysts are able to hit my ad hoc queries with a LLAP, and I'm okay with that. So in those cases, it's fine. But for a very faster processing query, for example, let's say if you're building something like Google search, then you have to think about fast performance. Means in milliseconds or nanoseconds, you need to have so many results coming out of it. So in those cases, you cannot go with something like Page or something like that, right? So you have to take a call with the advanced level frameworks. So that's what you have to take a call with respect to your business requirement as well. So never blindly go with just one framework, or when people say that, hey, I'm okay with this or that, you have to take a call accordingly that, okay, which will suit my requirement, whether I want really very fast performance or I'm okay with maybe an average performance also, which is at least not like MapReduce. So these are the things keep in mind, guys. Again, you keep reading books across for so many factors, but you have to really know a lot of stuff from the practical perspective as well. Now what I'm going to do, I'm going to quickly walk you through some slides so that you get some idea that what exactly is going to be the approach across for the Spark Sql and what are the things involved in it. And then after that, we will be only doing all the coding activity with this. Like I said, we will be using a Databricks environment. So first thing first, this I have already explained you. Yes, I've already told you that it replaces the Shark. It is for structured data processing. It is built on top of Core Spark Core. And you also have a Catalyst optimizer. Again, you can run it from the CLI, which is from the Spark shell. And you have all these data frames API, which could be defined as a row and column. We already saw an example with that, right? So let's see what exactly is going to be the case here. So this is a SQL context. Again, like I said, this is going to be very important. All the basic implementations are supported here. Then talking about your Hive context, this fully supports a Hive query. Like I said, even your SQL context also do support Hive. I will show you one example there. But for the complex queries, no, it will not be that great as well. So basically with that, and one more thing is, if you are installing Spark SQL latest one, then you don't need to even install Hive separately. It comes sort of pre-installed for you. Okay, so it's not like some people come and ask me like, okay, do I need to install Apache Hive separately because I am running some Hive queries also? No, you don't need to. Okay, so all these things comes sort of pre-embedded with it. Now look at this part. This is going to be important. The above query which you are seeing is your Python. Second is your Scala. What we are doing here, we want to create a SQL context object now. You can see here, I'm creating a SQL context object. In both the cases, notice one thing, that your Spark context is a part of SQL context. Very, very important thing here. So here, basically you have a Spark context, which you have to call it within your SQL context, which will create your SQL context basically. And one difference from, I think in the latest version, now it's not required, but still you should know. So if you're using an older version, this will be required. If you're using Scala, then once you have created the SQL context, you need to sort of import it as well. You have to say import whatever object you have created here, dot, this underscore means strict, means everything within that. It's like sometimes what happens is that this is not sort of showing up in your environment, especially when you've done some complex queries. So even if you have created SQL context, it do not come up in your environment. So you're specifically saying, I want to load this. I want everything within the SQL context to be loaded. So it was a challenge with Scala initially. So that's the reason this was required. In Python, this step was not required. But like I said, now if I use my Spark 3.x version, it will no more be required. So I will not do, even I think with 2.x also it will not be required. So I will also show you that it will be running without that as well. Now talking about data frames, I already told you data frame is just the change of representation, but it is analogous to your RDD only. Here, we are just having the named columns also along with it, but we are also storing it like a row of object. And one thing to keep in mind here is that when you're working with respect to data frames, everything which was there with your RDD, like you have all the transformations, action, all the things are also applicable for the data because this is also a data sitting into RAM only. It's also immutable. Everything is like that. Now, how you can create data frames? Either you have an existing data frame, create a new one. This is like a transformation. You may have an RDD, you can convert it to a data frame. We will also see examples of that, how that happens. Maybe you have some data files, like maybe you have a Parquet file, JSON file. Not only this, even using the TXT file also, means a log file also, you can generate a data frame as well. So even either you can do it that way as well. And that actually we do it by programmatically. How we do that? We will see this portion later. Look at this now. So let's say I have a people.json file, which is the JSON data. I would like to convert it to a data frame. So what I will do, I have a function called as JSON file. So I will say SQL context dot JSON file, and I will give this people.json to it. Now notice what it will just do. As soon as I will hit this, it will convert this data to my data frame here. Okay. So you can see name came up here, age basically from here will come up here, P code will come up here, and all the data you can see age is not there in first row. That's the reason it is null, right? And it will load the data for me. Now there is a small catch. This is again the internal working for it. Problem is here I had only 5 rows, so it was okay for me to do like this. Right? It was automatically able to infer my schema. But if you noticed here, in this case, my age was missing, right? My age was missing, which came up maybe in the second row. Here it came in second row, but maybe if I have a huge data, maybe this age could have come maybe after 10,000 rows, right? Now the question is, how the Spark will determine that what all columns I need? Because this JSON don't have any metadata also. If it was a Parquet format, Parquet we learned that it have the metadata also along with it. But here I don't even have metadata with the JSON also. Then how Spark will know that, okay, I need to have 3 columns. One is age, one is name, one is P code. When in case if age is coming, let's say after 10,000 rows or something. What exactly Apache Spark do in this case? So one thing to keep in mind, by default, Apache Spark have the fixed thing. I think in 2.x is 20%. They have not changed it. I don't know what's the exact part. Let's say if you have 1,000 rows in your data, then only 200 rows it will go and read. Okay. When you hit this command, it will go and read the 200 rows. And in the first 200 rows, whatever columns you have, it will say that, okay, these will be my columns. It will not go and read the remaining. So in, let's say in 201th row, you have this age column coming up, then it will ignore it. It will simply ignore it while reading. So what's going to happen is, this is the default way, just to ensure that we are reading all the data. You can change this number from 20% to maybe 1%, or maybe you can say, I just want to read my first row. So if you want to optimize, the reason I'm talking about, again, this is related to optimization. A lot of times we get the JSON files where I know that I have a fixed schema. What do I mean by fixed schema? Like, you know that, okay, whatever is present in my row 1, the same columns will be present into further as well. Means columns are not going to change. Everywhere I have the data. A lot of times this happens. In fact, most of the projects you will be getting the JSON files also in this way also. Now, in those cases, maybe if I have millions of rows or billions of rows into my data file, it don't make sense that I let Apache Spark to go and read this much of the code. Because if I do that, it will again add up to my performance. So better approach is, I will tell you a property later once I go to the coding section. Better ways, in those cases when you are really sure about that, tell it that go ahead and read only first row and create my schema for it. Don't go and even to the second row. I don't want you to go and read and spend your time on that. Clear, everyone? This is again a very important thing from your optimization perspective. Everyone clear on this part?
Yes, Shivan. So suppose we have taken the example 200 rows only, and there is a next row 201, and that row contains extra column. Then how can we handle that? Will this skip that column? Yeah, what would happen exactly?
We'll skip that column. That's the default nature of Spark.
Okay, okay.
There are configuration property for this also. You can go and say that, hey, if while reading, if something comes wrong, go and throw an error. Don't create data frame for me. So in that case, when something goes wrong and let's say it throws an error, then as a developer, you go and say that, hey, let me increase it from 20% to let's say 30%. So that is something then you have to go and debug and fix it out. So, but by default, so it depends on your administrator, how he has set it, all these properties for you. But by default, it will skip it. Clear, Pradeep?
Yes, Shivan, clear.
Any other question on this part?
Shivank, two questions. First one is, what if I want to selectively import only particular number of columns? For example, I don't want pin code. I just want the name and other attributes.
Very good question. This I will be teaching you while coding. This is in fact one of the major focus. We can also do that.
And what if there are mixed values in the JSON file if we have nested values or multiple values? How is that handled?
Nested values also we will be seeing in the code. I will show you all the examples, how complex data can come up, how nested data can come up, and how you will deal with all those scenarios. Everything will be simple. That's the reason I said it will take at least 1.5 to 2 class only in coding aspect.
Okay.
Any other question, guys? Okay. Now, similarly for Parquet file also, we have the same thing. You can define the Parquet file API. You can give your file names. Everything will work for you. Similarly, you also have a load section aspect. This is similar to JSON. No change with that. It's just that here what we do is we say, hey, load, give the name of the file, comma, what is the type of the file. Why this is helpful? Because what happens is I have this API for JSON file. I have this API for Parquet file. What about Avro file? I don't have any API for that. So for that, load will help me. Or maybe I have some different format file for which I don't have any API. So there is a way to handle it by using load API. I will show you both these things into the code again. So you can see all these things are supported. Now, in fact, they have much more. You can see here, right? Avro, HBase, CSV, MySQL, how to read them up. So for them, basically, we have a different way to do that. I will be showing you in the code itself. Now look at this one. This is interesting. Let's say you have a data present in your MySQL RDBMS. You want to directly bring it to your memory. So what is the approach you will think of? You will say that, hey, let me go ahead and maybe use a scoop, right? Scoop will bring the data to my SDFS. From SDFS, let me load the data to memory. Okay. But basically, that would be a long process. Maybe when you are doing the testing or development, it will be a little longer process. Why we want to use that? In production, I actually never do that, but I've written this down also here. But here, let's say if I want to bring it directly using this, then the way is I can say SQL context dot load. Now look at the further query. Can you see this sounds very much similar to what we have learned in my scoop as well? See this part. I'm gonna tell my URL. Okay, this is my URL, username, password. I'm gonna tell what is my table name and also the driver, what I need for it. Using this, I will be able to create connection with my Spark Sql, with my RDBMS, and will be able to bring it like a data frame for you. A very interesting thing. And in fact, not only this load, there are few more ways also. Using the JDBC, how you can connect. Once I will come to the coding side of it, I will show you that. But for now, I just want to make you aware that yes, using Spark SQL, you can easily go ahead and create a data frame directly from your RDBMS table. I think somebody was asking this question also sometime back. And I said, hey, hold on to Spark SQL and I will explain you this concept. Yeah, Sandeep, you were saying something in mental? I think you unmuted yourself. Okay, no. Any questions on this part from anyone? No? Look at this one. This is what I was telling you up that let's say if you want to read Avro format, then in that case you can say, hey, go and give my Avro file. But only thing is here, instead of just telling what is the Avro type, you have to give the full name. Okay, that's something you have to keep in mind. So I have to tell the full name that com.databricks.spark.avro because otherwise it will not be able to identify it. Now, these are a lot of schemas what we have. Let's see all of them basically in detail. So you can see here, let's say what I want to do is I want to see the column name plus I want to see the data type for it. Okay, I want to see the column name and I want to see a data type for it. So for that, I will say my data frame name dot d type. So you can say here data frame name dot d type. What it will do, it will tell me all the column names inside it and what are the corresponding data type for it. This is similar to describe command in your Hive or your SQL things. Again, these are just actions and transformation. I'm not going into that. Look at this one. So here, what I'm doing is I'm saying my data frame name dot count. It will tell me how many rows I have. I can say data frame name dot show and basically give how many records I want, just like take. Then it can return you the number of records also here. For example, you can see here, it is going to tell me that I have an age, I have a name, and I have a P code. And this is the output will also look like a tabular output. So this is how you can also see this. Look at the difference in the syntax on the SQL now, right? You're hitting the data frame name dot show. Now, similarly, you have all these commands. Let's see. So like, for example, if you say limit 3 means, first of all, you said data frame name dot limit 3. So what it did was it created from this data frame to this data frame. A new data frame got created because it's immutable with only 3 records. And then when you did the dot show, it is going to return you basically the query for it. Means the result what is coming out will be shown up. So in this case, it did the first level is a transformation. Then after that, it's an action. So in fact, if you look at this, what just happened is I have basically this as a chaining impact. Just like in RDD, we have the chaining. Similarly, in data frame also, we have this chaining here. Look at this one. So let's say when I hit this query, I have, let's say, a data frame, but I want, let's say, only the age column out of it. So I can do that by stating that I have a data frame dot select, which is going to be, I want only the age column. So it will return me the age column. Similarly, here I need more 2 columns. One is name, one is age. So here I will get 2 outputs from it. So using this, I can get that. If I would have to do it in the Hive query, I would have written select 2 different column names, right? Name, comma, age from your table or something. Here, it is going to be a little different from this. It's a shortcut way. Look at conditional things also. You can say your data frame name dot where, put whatever conditions you want to. You can say dot where age is greater than 21. You can see in your output also here that now you are getting only the age which is greater than 21 from your query. Any questions till this step? I'm stopping here for a minute. If you have any questions.
If we need to do some mathematical operations, means we have to use where only, or we have to use some other any conditions here, Shivank?
So where is the, think of it where as a filtering step, right? So if you want to do mathematical things in filter, yes, you can do that. There is nothing stopping you. But you can also do your mathematical also in your select statement as well. You can say data frame dot select. Maybe what you want to do, you want to increase your age by 20% for all the people. So you're gonna, or maybe you just want to add 2 more years to everyone. So you can say age plus 2. So now what will happen in your output? You will be getting basically age plus 2. Okay, something like this. Your, let's say you have age column here, maybe some more columns after that. Maybe age is 20, 22, 24, and so on. Right? And what you wanted to do in your output, you would say that your data frame df dot select, I want this age plus 2. So now your output will be 22, 24, 26. So you can even perform either in the select query itself or in the where, depending on your requirement. Clear, everyone? Any other question? Okay. So these are the commands. We have already seen few. Let's see few more. Now, this is just different representations which I wanted to show you here. So like we have just seen till now what we were doing, we were saying people df.select, we were giving the direct age. That's it. Some people prefer to do it in this way. They say dollar and then say your colony. That's also fine. Some people say that, hey, I want to be a little more explicit. So they say that, hey, I want to say, okay, this age belongs to my people df data frame. It is helpful when you are doing maybe a join queries or something like that. So that there should not be confusion. Okay, you're talking about column of this data frame or the column of other data frame. So that way it will be helpful. Though everything is doing the same activity, but these are just different representations you should be also aware of, so that if you see the code getting used like this, you should not get confused with that. Now, okay, that's a good one. I think that's the same thing, Pradeep, you were asking also. I already explained to this example. So here you can see, let's say you have this age, name, and P code. So here you can see that I want basically whatever age was there, I want to just add plus 10 to them. Okay, I want to increase their age by 10. So here I can say your data frame name dot select, you want the name, and plus you want a comma, age plus 10. So like this, you can see here 30 became 40, 19 became 29, 46 became 56. Okay, so like this, you can perform these queries. Now look at this part. Let's say you want to perform a sorting on some operation. You can also do that by saying dot sort. And here you're saying that I want to do sorting based on age and I want it in the descending order. So you say descending, DESC. Okay. If you want in the ascending order, you can say ASC. So it's up to you or how you want basically these outputs. Now this is interesting and important also. So a lot of times what we have to do is when we hit this data frame, what's going to happen is, so let's say, first of all, when you want to write, let's say some Sql query, so you will say Sql context or Hive context dot Sql, and you can write whatever query you want. Let's say you have a data frame df, so you can say select a strict from df, but this will throw me an error. This will throw me an error. Why? Because it will say that I'm not able to recognize what do you mean by this df here. What do you have to do in this case? In this case, you have to convert and treat it like a temporary table, which will be sitting into memory. It will be exactly the same like your data frame only, no difference. It's a copy, but the type will become like a temporary view or temporary table. It's just like this. A lot of times we have the data when you read it from a file. Let's say you're reading a number, it will start reading like a string. Now on that, if you try to do some operation, it will not work. Let's say you say +2. It will not work because it will say that, hey, you have, this is string. On string, you cannot do mathematical operators. So what you do in those cases, you used to do a typecasting. You say that, okay, when I read the data, though it's reading like a string, let me first typecast it to integer, which it can understand. Once it gets typecasted to integer, now I can do +2, right? Similarly, when I have a data frame directly defined, it do not understand it. But as soon as you convert it to a temporary table or a temporary view, it will work. Okay, so that is what we have to do. And to perform that, what you have to do, you have to say register temp table. So what you're doing now, this people df was my data frame, and you said register temp table, which is named as people. So you what you did, you created a temporary table called as people from people df. It's the same copy, but now in the form of temporary table. Now inside this SQL context.SQL, you have to say select strict from your temporary table. You will not give the people here. Otherwise, you will get an error here. That's one of the important things. Now with 2.x, in fact, we don't use register temp table. I have also changed it in the book. It's just that not an updated copy. So it's basically now create or delete temp view. There's a different command. I will show you that during the coding section. I will not be using the register temp table. Though it will not throw you an error, but it will give you a warning that it's got deprecated and it's not recommended to use it. It's not that performance friendly also. Okay. So now we have a better APIs for it. So you should be using that. So like I said, in the code, I will be showing you that. Any questions from anyone? Now I will take you to the database. But before that, any questions? Okay. Now the next thing which I'm going to do, I will take it a little slow because I want all of you to do this setup along with me. Just 1 second. Okay. So what I'm going to do is, whatever steps I'm going to perform, I want all of you to do this setup along with me, so that we can at least have the setup ready along with when we are working on this part. So for this part, what you all have to do, go to community.cloud.databricks.com. Can all of you do that? community.cloud.databricks.com. I just send this link. You can click on that. Oh, sorry. I think I send it to one person. Okay. Now, just listen to me now. And after that, you have to perform the steps. Do a sign up. Okay. In the sign up, you need to provide all your details, your first name, provide your last name, and then basically you have to provide your company, whatever you have, give, let's say, the company email, whatever you want to give the title, whatever you want to provide, phone number if you wish to, this is not required, and select this and say get started for free. Now, one thing to keep in mind, it will give you two options. Select the community version because that is only free of cost. If you select the first option, then it will keep asking you for your credit card details and then you have to create a new account only. So don't do that mistake. Select the community version. That's a free account that will work for you. Once you will sign up, it will send you an email. There you can set your password. Once you set your password, log in to this account from there. Okay, all of you do this. I'm giving you 10 minutes for doing this. All of you complete this part. Meanwhile, let me.
Sure. Where to select the community version?
I just send the link, right? community.cloud.database.com. Look at the chat.
Yeah.
So once you will fill up in the sign up, then after that it will say which version you want, community version or the paid version. So select the community.
Okay.
I don't want to create a new account. I think I might have a corporate one. Just allow me a minute. Let me bring up any one of my corporate account. to give you the importance of this, this is so basically sort of important that almost every company I work with, they all sort of ask me when I do testing, they ask me to do their testing on the database side. So I have account for almost every company. Yeah. Some companies have also given me paid accounts. Some companies have basically asked me to test it on the free account. I will tell you about both. So I have created account for almost every company. Once you are done, just type in the chat box done. Means once you log in, it should show you something like this. Okay, good. Manju, Aditi, Avinash. Yeah, do it from a local. It do not require VM. It have its own cluster. Why you want to simply make a system slow by running it on VM? Now close that. You don't need it actually now anymore. Okay, only 5-6 people have done. Everybody else also quickly do it. Yes, correct. Subhi. Finish it in next 2 minutes. Then I will start explaining this database environment. Last 1 minute, guys. If you face any problem, just ask me. It's a very simple step, but just that you need to fill some form. That's it. I want to make sure that all of you do this because otherwise in the database, you will not be able to do anything. Okay. I hope everybody's done. If anyone face issue, just let me know. I'm going ahead now. So I have just logged in with one of my corporate account, which was free. I cannot unfortunately use any paid account because I want it, first of all, very similar to what you have. And at the same time, I have already put down some code too in the same corporate account. And if I use the paid account, it will start billing their credit cards. Okay. So now, if you look at this, these are a lot of things which is there, right? Now, first of all, here, if you look at this, it will tell you that, okay, what are the common tasks you can do with it? You will see new notebook, create table, new cluster, new ML workflow, so on, right? So many things you can do. Even new jobs also, but for this you need to upgrade. It's actually very helpful. Uh, then you also have this read documentation. Recent you will have none. I have it because I just yesterday for your class I did something. And once it is there, you can also see you have import, export data, create a blank notebook, quick start. Right? I don't need all that. Now let's come here on the left hand side. Guys, don't do it now. I will give you the time to do it. So just listen to me very carefully. It's very important. Come to compute. Don't do it now. I'm just going to tell you later. From here, first of all, what you need to do. See, when you're working on it, you need your master machine, slave machine, all that, right? It's a free part. So definitely they will give you only one machine. So what I'm going to do, I'm going to create a cluster. Okay, let me create a cluster. So I'm going to say, hey, my cluster name is going to be, let's say, demo. Okay. I am going to use the Spark versions for it, whatever I wish to. You can see so many other. So let me not use any 3.x. Let me use, let's say, 6.4 extended support, 2.4.5. Anyway, it doesn't matter. But since you guys have 2.x versions right now with you, I'm using this. In my machine, I have 3.x. It's up to you. So see, one of the best thing here is, let's say, when you want to, you have built an application on some new version. And maybe you very quickly want to make sure that it's working on older versions or the newer version. You want to test your application. In that case, see the usefulness. You can simply come here, do a drop down and say that, hey, I'm looking for a quick version here on which I want to test. So for testing, it's also very helpful. So build your application in your own environment, bring it here and test it. That's where a lot of companies ask me to come to this so that basically they can test their code. Notice this part. It's telling me I have 15 GB of memory, which is free here. Okay. And if you don't use this for 2 hours, it will disable your cluster and so on. Because it's a free account. Definitely they don't want you that you do any production things here. Okay. So if you have like very small data to test and all, it's okay. Now, few companies who say that, hey, we want to test our whole application fully, which require maybe a cluster having worker node, master node. I need more than 15 GB of RAM. In those cases, they go for the paid account. They simply say that, hey, you go ahead and create the paid account. This is my credit cards. We will put on that and basically use this. So it depends on company to company. So again, for your client also, the situation will come a lot of times. So they will say that, hey, we want to test this application. You have to tell about Databricks. You have to tell it, okay, if we test it at a basic level, it's going to be free of cost. But if you want me to test the whole application on this, then there will be a payment involved. Okay? So you have to be very clear on these aspects. Leave the remaining thing as it is and create a cluster. You can see here, it is telling me that I have only one driver, which is having 15.3 GB, and I have 2 cores in that. Okay, I have 2 cores in that. This is also a question mark. This is also DB also given, which is called as Databricks Unit. Okay, it's sort of just like you have CPU, right? They give it DPU. They call it DPU. You can say that. Now you can click create cluster. It do take some time. Once it's getting created, you can see this green color icon moving up like this. Let it be basically there. Meanwhile, let me explain you a few more components. Now, once you're done with this, you can see you have multiple options. One is the jobs. For right now, you cannot do anything. It's actually very useful. That's the reason they have made it paid. Then you have a data folder. Here, you can put all your data. I will be showing you how we will be putting our data details and all that here. Then we have a search. You can ignore that. Recent will show you what all activities we did recently. Workspace is also going to be important. So workspace is where we will be keeping our notebook. So you can see here. This will be all the workspace with me, and I will be keeping my notebook basically here. Okay, so that's all we will be doing across in this case to work on this database. So what are the major things we're going to use? Workspace, data, compute we have just used to create the cluster. Let's come back and let me refresh it to see if it got created. A lot of times you have to refresh sometimes because even if it's created, it don't show up. And you can also see there is something called as a job cluster. So again, since you cannot create job in the free one, so here it will not show much right now. Otherwise, this have also lot many useful details what you can see from it. Okay. So once this will be created, let me tell you what we'll be doing. So first of all, once your cluster is up and running, that means you got your worker. Think of it just like you have a VM right now, which have your master, slave, everything in the same VM, right? Because it's a free one. Now what we will do, so when we will go to notebook, in notebook, it will be just like a simple Jupyter notebook. Now in this, you will be attaching this cluster with this, because otherwise how it will know that I have to basically use all these data sets, right? Basically, oh, sorry, what all I need to work on means on which machine I need to work. This notebook alone is nothing. It's just a blank page. Just like in your Google Drive, you can open your maybe MS Word. Same way, it's blank. I can't do anything with that. It's just a blank cluster for me. So that's the reason you need to attach this. I will show you how to attach that data. Now in this notebook, you will get an option. It will say that, hey, you can do it either with Scala, you can do it Python, you can do with R. You can choose any programming language and can work with that. Now, one more thing which will be required, this notebook will also require the data. I will give you a pretty huge data to work at today, which we will be using tomorrow. Today, we will just get familiar with all this. So data is what you will be uploading in the data folder, which I showed you already, the table part. And once you will be uploading it there, then basically you can access this data from your notebook also. Okay. This is what we will be doing going further. Let me come back to this. Now it should be done. Okay, it's still creating. So before it's getting created, you can't do much. Yeah, you can see now it became green color for me. Now what I will do, I will first of all go to my data folder. Okay. In my data folder, you will see something called as create table. Now, in my create table, you will see this. Let me repeat it again. Guys, this is very important. I will ask you to do all these steps later. So please make a note and don't try to do along with me, please. Otherwise, you will miss out some important step. Go to your data folder. You will see this create table. Click on that. Okay. It somehow got, okay. Let me refresh this whole database. Sometimes it just act weird. Again, this happens with the free of cost thing.
I think you already have it open. Maybe that's why.
Which thing?
Yes, you already have it open.
No, it's not. Okay. Sorry. Now look at this. Upload file. Here you can come and upload your data. That's number one. This is your Amazon S3. You can come basically from Amazon S3. So you can have the data. When you will start doing it up, it will ask your key and all that details. You have to provide it to authenticate and then bring the data. DBFS is the folder where you will be keeping, you can see all of that. So let's say you will upload it from here. You can see all this data from DBFS. This is the file structure. This is from other data sources. Like you can see here, we have so many connectors available. You can bring the data from Redshift. You can bring it from Amazon Kinesis. You can bring it from Cassandra, Snowflakes, JDBC, Kafka, Redis, Elasticsearch. You can see it's a vast resource pool from where you can bring the data. Then you also have some other integrations for that, which also you can use it. So it's a little more tricky to do that. Then you have to bring your drivers and all that along with it. But they say that, okay, we have these partners also, which you can use it to connect the data as well. But these are the standard ones. And generally, I have never used partners. I have used this one a lot. They have, especially the Cassandra data. I bring it a lot many times. JDBC, I have used it a lot because using my maybe some Java programs, especially when I'm bringing it up, I use this. Or even from Apache Kafka, I have brought a lot of data. Okay. Now, once this is done, let me show you how this will look like, or in fact, the data which I am going to give you, how that will look like. So if you go, basically you can see even the user folder here. You can see in user folder, there will be some default ones and all that. Like you can see it here. And you also have a file store. You can also see it here, like file store, table, retailer, data. Look at this. This retailer data is what I will be asking you to use. Okay. So in this case, I will be giving you all these files. It's a little bigger file. I will upload it on your G drive right away, and you have to bring it in this system. I will tell you how you will do that. So here you can see that I got basically this part. I have this retailer data, and here you can see all this dat files in it. You will also notice one more folder here. Let me show you. Okay, looks like I have not placed it. I will place it here in front of you then. There will be an image folder, which I will also create and place my data also here. So this is my retail data information, what basically I have created in front of you. Now, how to bring this up? How I can bring this slash retailer and basically place all this data. When I will come to this upload here, you can see it's telling me slash file store slash tables. Let's see here. Slash file store slash tables. Now inside that I can have retailer. Okay, inside that I can have retailer. So here, what I have to do, I need to come to this and I have to say retailer. That's the first thing. Okay, because I want to place all the data here. Then after that, I want to draw all the files to upload in this. Now, what's going to happen? This will take a good time. Yes. Basically, when you will upload, this will take a good time to get uploaded for you, but that's okay. I want it to be ready by today for all of you. Now, let me show you how this will whole look like. 1 second. So for me, retailer was already there. For you, it will create it once it will execute. But let me just show you how to bring this data. I'm just unzipping one folder and then I will show you. Okay. The file which I will give you, that will have two folders. One is a data folder and second is an images folder. Now here you can see I have all these dat files and all available here in the data. Select all, okay? And once you select all, go ahead and just drag it here. That's it. It will start uploading. Now one thing, when it is getting uploaded, please do not do any refresh of this page or anything like that, because otherwise you have to redo all these steps again and you will have a lot of troubles. Okay. Now what I'm going to do right now is, can you all first of all go and create your cluster? Number one. Meanwhile, I'm uploading your files for it, which is you needed for this particular lab, because I will be using a very huge amount of data sets here. All of you meanwhile keep on working on it. I'm just uploading this data set for you. It's getting uploaded. It will take its own sweet time. Meanwhile, have your cluster ready. Make sure that you understand the environment. You can see that here I have all these files getting uploaded, right? 0.3 GB, 0.1 GB, and after that it will come here. So it will take some good time. And below you can see all the files will show up, like inside retailer, all these things are getting uploaded. All of it do that. Once your retailer will be uploaded, I will let you know, then you have to download that. And once you will download it, you can basically go ahead and do the same step which I have explained you for now. Have you guys created a cluster? You can see it's still happening for me. Cluster created. Okay. Just go ahead and explore your workspaces and all meanwhile. Meanwhile, this data is getting uploaded. It will take some time. So meanwhile, if you want, you can go to your Google Drive. I have created inside your Spark folder, I have created Spark Sql. Inside Spark Sql, you will find the retailer.zip once it get uploaded. It will take its own sweet time because it's a little bigger file. But once it's available, you can basically, it will be available for you. Okay. Now, meanwhile, you guys are doing, I don't need to wait for it because I already have this data project. So I don't need to wait for it. I just want to show you the next step. Okay. Meanwhile, I hope everybody have created a cluster anyway, meanwhile, right? Now, let me explain you the next step. Guys, I need your attention again. So let's say if I come to this create table, I also need the image folder here. So what I will do here is I will say retailer/image. Okay, retailer/image. Now inside that, what you should do, in fact, make it as images, because I think in the code I might have used this folder. So you can say this, select all these files. Okay, select all these files and again drag it here. All the things will get uploaded to your images then after that. So ensure that basically first your whole data should get uploaded. Once your whole data should get uploaded, then only come to this images folder and basically perform the create inside retailer, create an images folder. And once it's created, then it will upload all the image for you. So 2 steps I have already explained you. First step, in fact, I told you multiple steps. First step, create cluster. Second step, come to the data, click on create table, go to upload. From your upload, give the path retailer and upload all your data files. Once that is done, then come to upload, again give a slash to it, give an image folder name, and once that is ready, upload all the images file for it. Okay. So these are the steps what you need to perform to bring your data as well as images folder. Once this is done, you're all set and ready to perform all your coding activity required here. Any questions from anyone first of all on this?
Where is the data?
Which thing?
This
Yeah.
image folders and all, where it is.
Yeah.
It is still getting uploaded. Unfortunately, it is taking time.
No, how we have to upload to our clusters.
Same thing, you have to just unzip. Once you unzip this retailer, it will look like this. So I'm
Can you
uploading
please share this link, Shiva?
Which link?
Data, this retailer data, where it is in local. Can you please?
He is yet to upload it in the Google Drive. Once that is done, we have to access it, download in our local, and then upload it here.
Let me show you basically what I am doing right now. That's what I'm also waiting for the link to. Link I can share, but it will be like this. Can you see this part? So this folder you already have, right? Inside that there's a Spark folder. Inside Spark folder, I've created a Spark Sql. This Spark
Yes.
Sql will get this retailer.zip, but it's taking time to upload because it's a big file.
Okay.
Okay. So this link you already have it, right? Big data
Yeah,
Spark.
Shiva. Yes.
So just that I am waiting for it to get uploaded. It's still showing me 11 minutes left. Maybe once the class is over, you can go and download it from this location. And once it's available, make sure that before tomorrow class, have your database environment ready. That's going to be important. So you need 2 things. One is your data and one is your image, guys, all of you. Okay. So this will look like this only. One is your data, one is your image. So first go to your data, do all this, come back, come to images, then after that put all this. Okay. Actually in the images, what I have done, I can give you an insight about that. In images, what I have done, I have given the explanation about these DAT files. Otherwise, they will find it hard to look at the schema on your own. So what I've done is instead of this, I have basically explained that, okay, in this data set, these are the columns, data types for all this, so that it's more easier for you to cope up with that. Clear, everyone? Okay, so I'm stopping here. Any questions now for today's session? What all we have discussed? Any questions on that?
So I have a question, Shiva. So we're putting Spark Sql on top of Spark, right? Like in previous class, you mentioned that there is a slight performance difference between Scala and Python. In the same way, do you think there is a performance difference between using Scala, Python, and SQL, Spark SQL?
No, there is no difference basically with respect to SQL and Scala side of the things. When you use Python, then only there's a difference basically, because there are a lot of things I don't want to go in detail, but just to give you a context, it still converts few things to JVM. It have to convert its object to the JVM format, and that adds up to the time. Here you automatically have the JVM, right, for Java and Scala. Here you don't have it. So it do perform some operations to convert it to that type of object.
And Spark SQL doesn't have it. I mean, does not have to. Does it have it built in like Scala, or like why is it special than Python?
Spark SQL coding, you can still, so see the difference will come like this, right? You will say val, maybe the name of RDD or data frame, whatever you want to call, and then you will say your SQL context, whatever you have created, dot SQL, and you will give your SQL query. Am I right? You will hit like this. Now, if you are writing in Python, you will write it like this: RDD is equal to SQL context dot SQL, and you will give it in this manner. Correct? So Python, when you will be sending this command, it still have to perform some operations, which will take some time for you, right? But on the other hand, when you're writing in Scala, that time will be saved for you. So that will be basically it. But let's say there is also one more thing. You can directly write your SQL. I will also show you that tomorrow. You don't need to use any programming language. You can directly write your SQL code also, means directly Hive queries. So that when you write,
Go ahead, sorry.
yeah, you write that, that is equivalent to this performance.
So yeah, that one other question was like, in how often do we actually use Scala or Python, and how often do we usually use Spark SQL working in real time?
Depends on the, I would say, comfort zone of the developers also. But if you want a comparison with this, if you're using Spark MLlib, I would say 80% of the people roughly statistically use Python. Reason being, if anyone who using Spark MLlib, they sort of prefer to go with Python. Okay. I don't fall in 80%, I fall in 20% because I prefer to write it in Java. That's my favorite language, and it's pretty fast also. Though Scala is also comfortable, but I prefer to write in Java. That's my comfort. Now, when it comes to basically in 20% Java and Scala both falls, but and even R when it comes to Spark, but it depends like which you want to go for. When it comes to other components, for example, let's say you are using streaming or ML, sorry, not ML, streaming, Spark Core and all that. That's where, if you ask me, more than 60% or 70% of people use Scala. Scala and you can also say Java. People also use Java interchangeably a lot. Okay, so the percentage for the Python developers here reduce a lot with respect to this. In fact, I think I'm a little bit on the safer side. It could be even 80% because I've included Java also here. And if you talk about some other components, like for example, how many people in Spark SQL works? I have seen people directly using SQL because they don't bother about Scala and Python at all here. They directly go with SQL. That's where the percentage of experienced people doing it is much more. Even I do like this. I prefer to go with the same way where I'm just writing SQL and getting my work done, irrespective of any programming language. I also don't use Spark SQL syntax generally. I generally prefer to go with the SQL web, SQL web.
So, so that includes building pipelines and bringing in data and everything, all kinds of operations, or any specific set of operations you prefer to do with SQL?
Yeah, even the pipelines and everything, I prefer to go with Java. My favorite language is Java.
Okay.
So when Spark came in the market, with Java 7, it was very tough to work because there was no functional programming. If you know Java, there was no Lambda expressions at that time. But as soon as Java 8 reached in the market, then people started going with this. Actually, because of Java 7 typical thing, a lot of people started learning Scala. Even I did that because of this. But then as soon as Java 8 came up with Apache Spark, I just started using it. I again came back to my Java.
So you're saying using Java 8 has made Java 8 is easier to use with Spark than Java 7. They have more specifically built-in functionality for Spark.
Yeah, don't even think about using Java 7 with Spark. You will break your head.
Yeah.
Frustrated with this because there is no functional programming. You have to write long code with that.
Okay. All right. That's all I have. Sure. Thank you.
Any other question, guys? Okay.
Shivank, I'm having issue creating the cluster. I tried like 3 times and then it shows as terminated.
I can't hear you.
The cluster after the creation, when you come to the clusters page, it shows as terminated.
It shows terminated. No, that should not happen. If that is happening, just delete it and again recreate. Or maybe sign out from your account and re-sign it. Some problem is happening in the account in that case.
Okay, all right.
You can just help on the Databricks page or create a new account because it's a free account, right? So they don't give that priority to those accounts. Okay.
Okay, Shivank. Yeah.
Yeah. Any other question from anyone, guys?
Is there any performance difference between Spark Sql and that Sql data frame syntax?
No, there is no performance difference. It's all the same. So basically, internally, it contains the same plan. So there's no difference with that.
Okay.
Any other question, guys? Okay. Then I think we're good. We will be connecting again. Make sure that tomorrow you have your lab set up. After 2 hours, your cluster will be gone, which is completely fine. Tomorrow, you can again recreate the cluster, maybe just before the class. That should be fine. And have it ready with you because tomorrow we are going to do lots and lot of coding in using our Databricks environment, and we will write a lot of code with respect to it. Okay, so be ready for tomorrow. It's going to be a big class. Thank you.
Thank you.
Thank you, Shivank.
Thank you, Shivank.
Thank you, Shivam. Thank you.